When you think about it, our bodies are just incredible. How do our joints stay so smooth? Or how does our immune system know exactly which cells are friends and which are foes? Well, it all comes down to some amazing microscopic molecules, truly the unsung heroes working inside of us. So let's dive into this hidden world.
So, what is this secret stuff? I mean, on one hand, you need something that's like a super lubricant, a shock absorber. And on the other hand, you need a totally different system, right? Like molecular ID tags so your cells can recognize each other. It sounds like two completely different jobs, but well, our body has a pretty brilliant solution for both.
And here they are, our two molecular superstars, glycosaminoglycans, we're just going to call them GAGs for short, and glycoproteins. Okay, I know, the names sound a little complex, but what they do is absolutely essential. Let's start with the first one, the GAGs. Okay, so the absolute best way to think about GAGs is to picture them as the body's ultimate water magnets. Seriously, their entire structure, their whole purpose is to grab onto water and hold it tight. And that one simple property, well, that's what makes them so incredibly powerful. So what is a GAG, really? Basically, it's a long repeating chain of sugars. But here's the key. These chains are super hydrophilic. They just love, love, love water. And that attraction is what gives them this amazing gel-like quality and makes them so good at resisting compression. And the building block for these massive chains? It's actually pretty simple. It's just a repeating unit made of two things, an amino sugar and a uronic acid. But, and this is the secret sauce, it always has at least one negative charge. That negative charge is the key to their water-loving superpower. So why does all that matter? Well, think about it. All those negative charges and all that water they pull in makes GAGs the perfect shock absorbers, especially for places like our joints. The best analogy? It's like a biological sponge. Imagine you jump, or you just put a bunch of pressure on the cartilage in your knee. That force physically squeezes the GAGs. And just like wringing out a sponge, water gets temporarily pushed out. That's what allows the tissue to compress and absorb all that impact without getting damaged. And then, the second that pressure is gone, something really cool happens. Remember all those negative charges on the GAG chains? They all repel each other, pushing away from their neighbors. This forces the whole molecule to spring back into its original shape. And as it expands, it just sucks all that water right back in, rehydrating the tissue and getting it ready for the next hit. And get this, it's not just one type of GAG. It's a whole family of them, each with a special job. You've got hyaluronic acid, which is the star lubricant in our joint fluid. Then there's chondroitin sulfate, which gives our cartilage its structure. Keratan sulfate is what keeps our corneas crystal clear. And then you have heparin, which does something totally different. It's a powerful anticoagulant that stops blood clots. And just to give you an idea of the sheer scale we're talking about here, a single molecule of hyaluronic acid can be built from up to 25,000 of those little sugar units. That's one gigantic water-trapping polymer. It's no wonder it's such an amazing lubricant for our joints. So if we sum it all up, GAGs are really the workhorses of our body's framework. They're providing mechanical support, keeping everything hydrated, helping prevent blood clots, and they even play a role in cell signaling and wound repair. They're just foundational. All right, let's shift gears and talk about our second superstar, glycoproteins. Now, if GAGs are the structural sponges, then glycoproteins are all about information. They're about communication. You can think of them as proteins that get a special kind of upgrade so they can do all these incredibly smart jobs. A glycoprotein is pretty much what it sounds like. You start with a protein, and the glyco part means a carbohydrate chain, a sugar chain, gets attached to it. But this isn't just some random decoration. Attaching that sugar chain completely changes the protein, giving it a brand new, very specific function that it just couldn't do before. And this upgrade can happen in a couple of main ways, depending on where that sugar chain hooks onto the protein. There's a way called N-linked, which is how we make our antibodies. And then there's another way called O-linked, which is how we make things like mucins, the stuff that makes our mucus all slippery. The main thing to remember is that these different attachments lead to proteins with totally different jobs. And just look at the list of jobs this upgrade allows for. It's incredible. Glycoproteins are our antibodies, fighting off infections. They're the markers on our red blood cells that give us our blood type. They can be hormones. They can be structural, like collagen. They even handle that crucial first step in reproduction, sperm-egg recognition. They are the ultimate cellular communicators. So there you have it, our two molecular heroes. One is a master of structure and hydration, and the other is a master of communication and identity. Let's just put them side by side one last time to really see the difference.
Let's boil it all down. GAGs, they're mostly just long, repeating sugar chains. Their main gig is to form a hydrated structural gel. Glycoproteins, on the other hand, are mostly protein with smaller, way more complex sugar chains that act like sophisticated signals for recognition. So, to put it simply, one is the cushion and the other is the ID tag.
And that brings us to this really cool idea from the source material. Scientists call these molecules information-dense biopolymers, which means they're not just dumb building blocks. No way. The complex shapes of their sugar chains actually encode a huge amount of information, directing everything from how our tissues form to how our immune system responds. So the next time you move a joint or fight off a cold, you can thank these incredible information-packed molecules working silently behind the scenes. Makes you wonder, what other hidden codes are running our biology?